This is for year 11 methods. We're going to look at 2H, which is last exercise, question number 9. So this is to do with simultaneous equations. Now this is an example of one of the more harder to speak question in which we need to apply simultaneous equations in order to solve it. Okay, so let's read the scenario. John and Michael race over 50 meters. John runs so that it takes 8 seconds to run 1 meter, and Michael runs so that it run 1 meter. Michael wins the race by 1 second. The next day they race over 50 meters, but Michael gives John a 3-meter start so that John runs 47 meters. Michael wins this race by 0.1 second. Find the values of A and B and the speed at which runs. Okay. So let's break this question down because we're given quite a lot of information. We know that there's a race and it's over 50 meters, so that's the distance. Now, for speed questions, I always want to write my triangle. So distance, speed, time. This actually gives me an indication of what the relationship is, and what if I want to find time, I can get it in terms of distance and speed, and etc. etc. So we know. Okay, let's go John and Michael. We know John's speed is 8 seconds to run 1 meter. Remember, this speed equals distance over time based on the triangle. So John's speed is distance, which is 1 meter over time, 8 seconds, A. Mike's speed is 1 meter in B seconds. So their speeds are 1 on A and 1 on B respectively, and it's in meters per second. So these speeds are in meters per second. You always need to check the units because sometimes in the book they try to trick you. So if they're not in the correct units, you might get the wrong answer. Okay, so we know that in a 50 meter race, Michael wins a race by 1 second. Okay, so let's do a comparison in time. Okay, so I'm going to do an equation comparing the times. Okay, so time is distance over speed. Okay, so the time taken so I'm going to do an equal equation. So we know that John's time is distance over speed. So what's John's distance? 50 meters over John's speed, 1 over A. Mike also ran 50 meters and his speed is 1 over B. So I'm just purely equating the time, okay? And this is the expression for John's time, this is the expression for Mike's time. Now, we need to take into account that Michael wins the race by 1 second. So this is John, this is Mike. If Mike wins the race by 1 second, Mike is 1 second quicker. For John's time to equal Michael's time, you need to add 1 second for the time to equal John's time, because John is 1 second takes 1 second more to run the race. Okay, so this is essentially one of the simultaneous equations. Okay, because we've got a relationship between John's time and Michael's time, and we know that John is 1 second slower. Okay, so which is why I've added 1 second to make them equal. So this is really important that you understand that the equality. Now the next part is next day they run the race over 50 meters, but Michael gives John a 3-meter start so that John runs 47 meters. Okay, so in this case, we're going to equate time again. So we know that John has a 3-meter start. Okay, 3-meter start. So instead of John instead of John running 50 meters, he now runs 47 meters. So it's distance over time. Time is distance over speed, so 1 over A. And Michael's still running the full 50 meters, so 1 over B. Now, the relationship is that Michael wins. So Michael wins. Michael still wins, but by only 0.1 of a second. So again, John is 0.1 slower, so I need to add 0.1 to Michael to make them equal. Okay. Now I've got two equations. All I need to do is use my CAS and solve this. So I'm going to go edit, clear all. Okay, let's start from scratch. I'm going to insert both equations. So 50 divided by 1 over A. Okay, I'm just going to call it X. I'm just going to call AX, okay, just for convenience, because I don't want to use the other menu. So this will be 50. Oops. Let's draw again. 50. 1 over, call that Y, plus 1. And I forgot to put this in a simultaneous equation. So I'm going to cut this and paste it on. So the good thing about this is you can cut and paste. So I'm going to delete that. Second equation is 47. 1 divided by X equals 50. 1 divided by Y. Divided by Y. Plus 0.1. And we're trying to solve for X and Y. Okay. So we can see that if I change that to standard, X is 3 on 10 and Y is, or A is 3 on 10, B is 7 on 25. So A is 3 on 10 seconds. Oh, oops, go back. A and B is 7 on 25. Now, we want to find Michael's speed. So Michael's speed is 1 over B. So we know B is 7 over 25. So 1 over B would be just the reciprocal of it. So it's 25 on 7 meters per second. Hopefully that helps.